Hi class, for this video I just wanted to introduce the special cases. And technically this is what we have. So the vast majority of problems in this lecture involve case number one, the one that there exists a solution, meaning that if you were to solve a problem in this case, for this specific one, if you were to subtract by 2, you would actually end up with the values of x is equal to 10. And this will be your solution. If you were to check, well, you would evaluate x is equal to 10 into x plus 2 is equal to 12. And you wouldn't expect anything or any surprises to occur here, because if you're looking at this one, well, you're going to have 10 plus 2 is equal to 12, or 12 is equal to 12, which means it checks out. Now, here's the problem. Not all the problems that you're going to be solving for the equations, you're going to find case number one where you're able to solve it and then you plug in the solution and it works out. For example, let's take a look at case number 2, which is the no solution. Now, in this situation, if you were to solve the equation, something happens as you try to rearrange the x's or put them in one side of the equation. Now, remember the rules. The operation you do to one side, you have to do it to the other side. So in this case, if you like to put the x's in either side of the equation, you end up with, well, technically x minus x is 0x plus the values of 2 is equal to 12. 0x is technically 0 for the x's, so you end up with 2 is equal to 12, which is technically false, a false statement. And here's the basic idea on the no solution case. Because you end up with a false statement, no value that you pick is ever going to give you a true statement. So for any equation that you're trying to solve and you obtain a false statement, and that occurs once your x's cancel out, you would automatically say no solution. So basically 2 is equal to 12 is false. In this case, this is a no solution. Some of the problems, like on the homework, they may ask for the set. In this case, the set, it's going to be the empty set. And the empty set represents the set with no values. So you can rewrite it as squiggly brackets. That's what I'm trying to do here. I'm rewriting it with squiggly brackets, or the empty set, it's a 0 with a line across. And in this situation, depending on what they're asking, some of the problems on the homework may just have a button for you to fill in, or to select the empty set. Then the empty set means that, well, the actual equation has no solution. No value that is selected will ever provide a true statement. Like on the previous one, 12 is equal to 12. So no solution. And once again, that happens after the cancellation of the variables in a false statement occurs. The last case that we need to talk about is the infinite amount of solutions. So in the infinite amount of solutions, we have like the same process that occurred on the no solution. For example, if we were to solve this problem and rearrange the x's, you would notice that your x's go away. I'm just going to rewrite it as 0x plus 2 is equal to 2. And in this case, our x's cancel out. So we end up with the values of 2 is equal to 2, which is true. But here's the problem. In this specific true statement, we don't have x is equal to a number. As a matter of fact, your x's cancel out. So if your x's cancel out and you don't end up with x is equal to a number, like for example, on case number 1, where we ended up with x is equal to 10, in this particular case, any value will work and any value will give you a true statement. So automatically, once your x's cancel out, you would basically say infinite amount of solutions If they want a set, they can rewrite it as follows. So this will be the set of x's such that, and this is x is a real number, or you can spell out number, which actually means that any value is going to satisfy the equation. And once again, these cases of the no solution and the infinite amount of solutions may show up in the homework assignments. They're going to show up in later modules, and I thought it was a good idea to introduce it here at the end of this one, since the majority of problems that we're dealing with happens to do with a single solution. So once again, special cases only occurred once your variable cancels out. And let me just pinpoint where the variable's canceling out. And this is typically here. These are only like a couple of steps and your variable cancel out. And that's either going to lead you to a false, automatically no solution, a true, infinite amount of solutions. That's actually it for this example.